And I am Christian Spanish-Schmidt, hospitalist at Danbury Hospital. Welcome all you students. We are very happy to have people from UVM, and this is for you. Thank you for coming here. And now I would like to start with our class today, and this is the part 1, and of course, because there is always part 2. And I just want to start out with some basic concepts. The first basic concept is that I want to call acidemia. Acidemia is always a low pH. Then alkalemia is always a high pH. Then acidosis is a condition causing an increase of acid in the blood or a decrease of base in the blood. It doesn't matter how you see it, regardless of the pH. And then we have alkalosis, a condition causing an increase of base or a decrease of acid in the body, regardless of the pH. So these are the basic concepts that we are going to work with. Now we are going to talk about certain golden rules. So the first thing is that a normal pH just may reflect that the patient is normal. Also, chronic respiratory alkalosis may have a normal pH. And of course, a mixed disorder. This is very important because mixed disorders are very common when we see normal pH. A normal compensation will never ever bring the pH to be normal. And this is very important to remember. A second disorder should be looked if a normal pH is found in a patient with an acid-base disorder. And that one, I really want to make it louder. So a second disorder should be looked for if a normal pH is found in a patient with an acid-base disorder. A single patient may have up to 3 disorders: 2 metabolic, 1 respiratory. So you can have metabolic, like anion gap metabolic acidosis plus metabolic alkalosis. You can have anion gap metabolic acidosis plus metabolic acidosis on top, but you can only have 1 respiratory, and this is very important to remember. Of course, there are more rules. The next one is throw the normal values away. So how are we going to do that? Well, the thing is to make things easy. So we're going to stick to this. The pH is always 7.35 to 7.45, and that's because our body is very good at maintaining it. HCO2 is always 24 millimoles per liter. This can change if you are, for example, in Europe or somewhere else, but here in America, this is how we do. So the PaCO2 is always 40 millimeters of mercurium, mmHg, and then the anion gap is always 12. All our results for calculations should be adjusted plus minus 2. We are not extremists. We need to make this adjustment. Then, of course, more rules. So, more rules. The first is that respiratory correction for metabolic acidosis will not bring the PaCO2 above 55. If that's seen, there is a primary respiratory problem. So, if you see a patient who has a PaCO2 above 55 in either the text or the test or live, you need to be worried about this patient. And then metabolic correction from respiratory alkalosis will never bring the bicarb above 40. And if that's seen, there is metabolic alkalosis. So it's very important to remember these rules. And again, all of our calculations are approximate, and they are many things that can affect the acid-base status. Next one, never say overcompensation. You really don't want to say that word. Compensation is a word that suits the heart of the physician and may lead to missing a disorder. So if you see for example, transitory normal pH in a patient who has DKA, who is overbreathing, or has metabolic alkalosis, this patient is not going to do well if we don't take the steps that are necessary to treat the patient. Well, so in the next one, call it for what it is. Overcompensation is a mixed disorder. Overcompensation is a mixed disorder. So we're going to talk about our first disorder. So now I wanted you to look at the pH, look at the bicarb, and if you have an ABG, look always at the PaCO2. The oxygen, the oxygen is out of this specific talk, and we're not going to talk about oxygen exchange. In normal or low pH with low bicarb, always calculate the anion gap. So the anion gap is sodium minus chloride minus bicarb. This is what we are looking for. And there are two ways to correct for albumin. This is very important if they are giving you a patient with low albumin. So if the patient has a 3 of albumin, just bump 3, whatever you got from the anion gap, or use the formula. The formula is always work every time you use it with an albumin less than 3.8. But if, let's say that you have an albumin of 2, it's very easy if you just go and say and say 6 on top of the anion gap. Okay, so if the anion gap is more than 14, you can confidently say anion gap metabolic acidosis. At this moment, you are happy and you will feel good for yourself, and you are going to move to the next disorder. So you feel good for yourself. You calculate the anion gap. So if the anion gap is less than 14, then you can confidently say primary metabolic acidosis. And at that moment, you feel good for yourself and you look for the next disorder. Again, if anion gap is found, you wanted to look for the expected bicarb. So in that, our method is very easy. I have made it as easy as possible, and this is how I was taught. An increase of 1 of the anion gap should decrease by 1 the bicarb, as easy as that. So if you're looking for the expected bicarb is 24 minus the anion gap minus 12. So as you can see, every time the anion gap goes up, the bicarb should goes down. And then if the value of the bicarb is above what you expected, then it's alkalosis. High bicarb is alkalosis. And if the value that you are getting or expecting is less than what it is, then there is primary metabolic acidosis, and this is how you find out that the patient has mixed disorders. So, such a relief, right? Excellent. So you have done a great job so far, and another one. The problem is that now you need to figure out what's the respiratory status. So the pulmonologist is looking at you, or the nephrologist is looking at you, and now he wants to know if you know the Winter's formula. Winter's formula is basically 1.5 times the bicarb plus 8. That will give you the expected PaCO2. Of course, If the expected PaCO2 is higher than the measure, then there is respiratory acidosis. And if the expected PaCO2 is lower than the measure, then there is respiratory alkalosis. So either the patient is underbreathing or overbreathing. Of course, you can always check at the pH. Let's say that you have a patient who has metabolic acidosis and metabolic acidosis, anion gap, and primary, and then you have a pH that is high. So, well, then this patient has a respiratory problem. Now, it gets a little bit foggy when you have mixed disorders in metabolic mixed disorder, like an anion gap, metabolic acidosis, and alkalosis. And then you have a low pH. Is this driven just because of the metabolic part or because of the respiratory part? One way to see it, if the patient is obtunded and if the patient is breathing like 12 per minute, which sounds like a normal value, at this moment may not be a normal value. So this is very important in the test, because they could give you a question, right? Like you have a patient who already has for what we calculated has anion gap metabolic acidosis and has a very low pH, and the breathing is about 12. 12 sounds like normal, but at that moment it's not. Or they give you something more easy, like a breathing of 8 per minute. That is definitely under breathing or agonal breathing. So you can actually figure out that. But if you know the formula and you can apply it, well, you will have a better step on the question. And these formulas are easy to implement even in the test. So the other thing is that pure metabolic alkalosis. This is something that is not taught a lot in acid-based books, and the reason is that we don't have a lot to offer. But so the pH is normal or high with an increased bicarb and no anion gap. And the next step is always check the expected PaCO2. And this has a different formula. It's not anymore the Winter's formula, and it's 0.7 times the bicarb minus 24 plus 40. It's easy to see that we are fine. The 40 is our normal PaCO2, and because you have alkalosis, you should have a decrease of your breathing in order to get compensation, and this way is the way to do it. So you add this 0.7 to HCO2 minus 24 for the compensation. And higher than expected means respiratory acidosis, of course, and lower than expected means respiratory alkalosis. And then you make diagnosis. But of course, you can quickly look at the pH, and the pH is normal. Likely the patient has another disorder and the patient is overbreathing, if the patient just has pure metabolic alkalosis. And if the pH is slightly higher than the respiratory, is probably okay. And if the pH is low, well, look at the patient, because likely there is respiratory failure accompanying this metabolic alkalosis, which is clearly something that we see a lot with patients who had COPD. They have high bicarbs, and then they will have a very acidemic pH, and that tells you that this extremely high bicarb is likely a compensation plus low volume plus the respiratory failure of the patient. So when they are giving you questions in the board, which I expect they are going to be slightly different now, because now step 2 is going to be the ruler of the boards. So it's important to know these differences. So then, of course, we have the respiratory disorders, and respiratory disorders, they are easier than it looks. I know it sounds imminent, but they are easier than it looks. And I just want to start with these numbers. And what are these numbers? That's a question, right? What are these numbers? And the numbers is 1, 3, 2, 5. 1, 3, 2, 5. And this is very important because despite that it sounds scary, they are the base of it. 1, 3, you're going to use it in acidosis, and 2, 5, you're going to use it in alkalosis. Wait, what? Yeah, you're going to see. So let's say that you have a low pH with a PaCO2 more than 50. Well, if you don't find anything else, you may want to start checking if there is always anion gap. If there is always anion gap, you can use the other ways that I just told you and go to the Winter's formula. But let's say that you don't find anion gap and you don't find another disorder, and you're gonna see that the formulas are not very different. A pH less than 7.27 will tell you that there is acute respiratory acidosis, and you would like to know what is expected bicarb. So how is the kidney fighting against this? So, and when you have a pH more than 7.28 and PaCO2 more than 50, well, so you will say this is likely chronic respiratory acidosis. And this is when the numbers I'm telling you come handy, because the formulas, just look at the formulas, and the formulas don't really change much. It's always PaCO2 minus 40 divided 10 plus 24. And then it's PaCO2 minus 40 divided 10 times 3 plus 24. So here, you always can look at the bicarb and infer if there is metabolic acidosis, check how bad the pH is, check for obvious stuff. But let's say that you need to calculate. So as you can see in the first formula, you multiply the last values, PaCO2 minus 40 divided 10 times 1, because this is acute, so the kidney does not have a lot of time to do any compensation. And then the second one, you multiply by 3, the PaCO2 minus 40 divided 10 by 3, because the kidney does have more time for compensation. Of course, there are places where you would like to, let's say that you know your patient from before, and now you are going to calculate the chronic and the acute compensation. But this is for sure not going to happen in your boards, and I don't think any one of us is going to ask you to do that, except if you are rounding with me. Now, let's say that you have a high pH, so you have alkalemia or normal, right? And a PaCO2 less than 37. So then you look at the formulas and they are almost the same, so just with different things. The pH is more than 7.52 and acute respiratory alkalosis, and then you look for the expected bicarb. And if the pH is less than 7.51, this is like chronic. And as I said at the beginning, chronic respiratory alkalosis is the only acid-base disorder that will bring your pH to normal, because the body has time to adapt. And now see a little bit how is different this. It's again the PaCO2 minus 40, but now 40 is at the beginning of the PaCO2 because the PaCO2 is going to be lower, so we cannot have negatives. But if you just leave it like that and you just like, okay, I'll take it, and I just put a positive in my calculator, divided 10 times 2, this is going to be the acute compensation. And then the chronic compensation is times 5, and it's not very different from the prior formula. You always, again, can look at if there is any metabolic acidosis. You can just use the metabolic acidosis pathway. And you can always check for anion gap. And if there is a pH that is too low, okay, so suspect that there is a second disorder. And if the pH is too high, suspect a second disorder. So here is where 2 comes, and here is where 5 comes. So 1, 3, 2, 5. Those are the numbers that you need to remember. So I'm sending this PDF to your program, so you can have it and you can hear this video, and you can rehear it, so it's easy. It's not a long video. And then it's very important to remember that we also have the urinary anion gap. Basically, the urinary anion gap, it's the sodium plus the potassium minus the chloride. And what we're looking is for NH4. So we're looking for failure to secrete protons, or a failure to get bicarb and overload the secretion of protons. And it has a high correlation with a low NH4 and loss of base by the kidney, which is going to give you a urinary gap of more than 10. And a urinary gap more than 10 means that there is a urinary gap, and there is then, therefore, there is loss of base from the, or inability to keep all the base in the kidney. And if you find the right place, a primary metabolic acidosis, then you need to look at the patient for the obvious. So the obvious is, like, let's say that this patient has a pancreatoduodenal fistula, or the patient has diarrhea, or the patient has parenteral nutrition, or the patient has a rectosigmoid fistula or retrovesical fistula. This patient might be losing his base, or over getting chloride from one of those. And of course, the patient is on IV fluids that also will give you a high increase of chloride, and that will likely increase the bicarb and decrease the bicarb. I'm sorry, and that will also be associated to primary metabolic acidosis. Now, if you have a high urinary gap, likely you will have RTA in the right setting. So this is the first video, and thank you very much for listening. We are going to see each other on Thursday, and I hope the second part is going to be interesting as well. Thank you very, very, very much. This was Christian Spanish Meet. I'm a hospitalist at Danbury Hospital, and I'm really, really happy to have you here. Welcome to the UVM students.